Okay, folks, so we're going to look at um, obviously maintaining programs and making robust and maintainable programs. And one of the first things a programmer or a software engineer needs to think about when they're creating a program is the potential for it to be misused. And if it is misused, can it be cracked? As in, can someone get into it and actually get sensitive data from it or get it to yield sensitive data by doing various things to it? Or is it possible for people to damage it in some way or cause it to crash through misusing it? So we're going to look at two types of misuse now. We're going to look at the first one here. We've got Ethel, and Ethel is signing up for an online social media platform so she can contact her family on the other side of the country. She wants to speak to her grandkids through video messaging. And what she will end up doing is something called accidental misuse. Right? So what it is basically, in a nutshell, she does something like, instead of reading first name correctly, she's not got her specs on in this particular instance, although she is in the photo, she doesn't at this point in time. She reads that as age for some reason, so she types 81 in. And when she goes to click submit on the form, the actual software has not been very well developed. It's not been planned in terms of understanding if there is going to be any misuse. And so what it does is it crashes and she can't access the software. Then she's got to reinstall it. Which can happen if programs aren't developed the right way. So accidental misuse is through no fault of her own, user makes a mistake in an input and this causes a poorly designed piece of software to crash. Or potentially, which is quite bad really when you think about it, yields sensitive data as it has been confused by the erroneous input. Right, erroneous meaning in error. So that's one form of misuse. So we've got Ethel doesn't mean to do it. She accidentally types in her age instead of her first name there. That's not an expected input. Computer gets really confused. Software's not been designed to handle the wrong input being put in, i.e. an integer instead of a string. And as a result, we get obviously it crashing or potentially yielding sensitive data because the computer's been confused by that erroneous input. So we're going to look at another type of misuse now, which is deliberate misuse. And we've got Sid, the hacker. And you know Sid's a hacker because he's wearing a balaclava in front of a laptop. And he's also got boxing gloves, which I'm assuming he's going to use to attempt to sort of free the laptop of this chain and this padlock. Obviously, one of my hobbies is to Google images of hackers and stock photos of hackers because some of them are hilarious. People smashing computers with hammers and things whilst wearing a balaclava. Not really what hackers look like, but there you go. So Sid the hacker, in a similar vein to what Ethel was doing earlier, Sid will also, in this input field and in other input fields, put strings of characters that he knows are going to potentially confuse the system. Now, they could be what we call an SQL injection, or he could just be putting strings of erroneous characters in that confuse the system, or he would know would confuse a very basic, simple system and cause it to either, as we said, yield sensitive data or crash the system. So similar to, however, the hacker is deliberately inputting the wrong data in order to either crash the program or gain access to sensitive data. And that could be actually accessing the system by sort of getting past this basic level of security, like typing in your names and things. So these are really important things for software developers to consider. All right, if you think about it, even the accidental misuse could cause the program to keep crashing for users and may not give them the best experience. They may migrate to a different program that does the same sort of thing, and you don't want that to occur. The deliberate misuse obviously is a massive vulnerability and a massive security threat for people if they're buying this software and then someone might be able to infiltrate their system through that faulty software because they're able to get access to that and then therefore get a foothold into the system as a whole. So this in itself is a vulnerability, which means weakness that can be exploited. Okay, so that's why we anticipate misuse as software developers. Moving on then, we've got the idea of authentication. Right, and what that means is ways users can prove they are valid, or should we say allowed, make it a little bit simpler, to use the software. All right, now there are different ways of authenticating. The first one I've got here is biometric. And this is basically things like retina scanners or iris scanners or fingerprint scanners or any other thing that kind of scans things that are unique to your body. For example, facial recognition. That is something that we have on mobile phones and smartphones nowadays, is a form of biometric. So my smartphone scans my face if I'm not wearing my glasses and actually can tell who I am. Still a little bit dubious about that, but supposedly it's very, very accurate in terms of matching to a particular face. Even very similar looking people can't get into each other's phones. Obviously, we've got password, which is a standard form of authentication. So you can't get into the system unless you've got that password. And another form is electronic key. So these electronic keys were quite popular sort of within the last 10 years for online banking. You can see this one here actually says Lloyd's TSB on it. So when you log into the bank, you're also asked to provide a one-time generated code, which the bank kind of runs through a special algorithm and knows that you are a legitimate user because you've got this special key that supposedly got certain numeric data that relates specifically to a code that's in your account setup. It's very clever the way it works, and it means that somebody can authenticate themselves, that word authentication, to the online bank to prove who they are. Okay, so that's what authentication means. It means the ways we can prove we're allowed to use the software, i.e. biometric scans, passwords, electronic keys. Sometimes we might want to combine more than one. So you might have a password and a biometric, or you might have a password and an electronic key. And we call this two-factor authentication. So these are methods, obviously, that enable us to prevent misuse of software through needing to actually have quite tight security. So you know that someone's not going to get in and start messing around with the software because they've got to get through this stage first, this authentication, providing one or many of these things. And actually, as well as two-factor authentication, we can sometimes call it multi-factor authentication.